Okay, as you can see, if you have checked your self-assessment sheet for this unit, we are nearing the end. This is, I don't have it with me, so this is either one of, or if not the last objective on your self-assessment sheet, solving fourth degree equations. So if I'm trying to answer the question, how can we solve equations in the form x to the fourth plus bx, and it is supposed to be squared. I'm sure Dalton is yelling out mistake right now. So x to the fourth plus bx squared plus c equals 0. The nice thing about these types of equations is that if I am trying to solve them, I'm going to use some methods very similar to that I've used with solving quadratic equations. Now, if I were taking these notes in class or giving this lecture in class, I would probably tear off one of those big pieces of paper, stick it on the board, and do my notes in the form of a big tree diagram. So if you would like to do that, please feel free to do so. My screen that I am given with the program I use to record these isn't big enough for me to get all my information in a factor, to get all my information into a tree diagram. So I'm going to set it up as one, and then I'm going to kind of break from the tree diagram form. So I'm going to start with saying, how do I solve these types of equations? So x to the fourth plus bx squared plus c equals 0. So once again, like before, notice I have to be equal to 0 in order to use these types of equations. And also, I'm going to work on having a coefficient of 1. When I have a coefficient of 1 and I am equal to 0, I am going to use one of two methods. The first being factor sum tables. And the second one being a special formula. Here, I can't squeeze it in. This is why these are so nice. When I use factor sum tables, I am again going to do factors of the last, or my constant term, and a sum of the middle, also known in this time as my quadratic term. So with quadratic terms, my middle term is linear. With x to the fourth, here my middle term is quadratic. But I'll do factors of the last and the sum of the middle. Now, the difference between these is before I would set it up as x plus or minus something times x plus or minus something. Very similar, but in the front of each of these sets of parentheses are two things that are going to multiply to give me x to the fourth. Well, x squared times x squared gives me x to the fourth, so instead of putting an x in the front of each of them, I'll put an x squared. I'm still going to take the numbers I get here and put them into my parentheses. That is how I will factor it. The special formula I'm going to use, again, very nice, is going to be a squared minus b squared equals, I bet you know, a plus b times a minus b. The difference now is, how do I get a squared? Well, isn't x to the fourth the same thing as x squared times x squared? So isn't x to the fourth just x squared squared? So the difference is when we use this special formula, a lot of times we're actually going to see it not written as a squared minus b squared, but a to the fourth minus b squared. But we will still treat it the same way, and it will break to be a squared plus b times a squared minus b. Kind of a funky two there. So now, as I said, I run out of room, so I have to grab another slide. I don't think it'll interrupt anything in terms of what you're watching, but it's going to break me out of my tree diagram. Because what I'm going to do now is I'm going to go over some examples of each type. So if this were me taking notes, I would put my example of factor sum tables right underneath my branch of factor sum tables, and my example with special formulas right underneath my branch of special formulas. But I will just do each one separately on a separate slide. So if I look at the first example I would like to do, the first example I would like to do is, how can I solve x to the fourth minus 2x squared minus 8 equals 0? Well, I notice that this is in the form x to the 4, I notice that this is not in the form perfect square minus perfect square, or perfect 4 minus perfect square. So I am going to go ahead and try to do factor sum tables because I do notice that I have a coefficient of 1 here. So I will do factors of the first, or excuse me, factors of the last, which is -8, and a sum of the middle, which is -2. So if I'm trying to find two numbers that multiply to give me -8 and add to give me -2, I notice that -4 times 2 gives me -8, and -4 plus 2 gives me -2, so those do work. So remembering that because it is x to the 4th, I cannot put the x in front of each of my factors. I must put an x squared minus 4 and an x squared plus 2. Because my original function was equal to 0, I need to bring that 0 down, and this is still equal to 0. I do want to point something out before I continue with the solving process. This is not in its most factored form. I could factor this piece further because this piece is in the form a squared minus b squared. I could rewrite this as x plus 2 and x minus 2. However, in order to solve it, it is not necessary for me to have it in its most factored form. So I'm not going to do that, but just keep in mind that if I were asked to factor something in like this, instead of solving it, I would need to factor this further. Going back into the solving process though, notice that I now have this times this equaling 0. So what is that property we keep using? It's that zero product property that tells us if two things multiply to be 0, one of them has to be 0. Well, now I can solve each of these. I have just an x squared term, so I know how to solve quadratic equations with just x squared. So I'm going to go ahead and add 4 to each side. Sorry, I didn't write that step in. And then I'm going to go ahead and take the square root of both sides. And I do get x equals, remembering my plus or minus, the square root of 4. Because 4 is a perfect square, I know that the square root of 4 is just plus or minus 2. And I also have to solve this equation here. So solving this one, I'll subtract 2. I'll write my steps in this time. And I get x squared equals -2. Once again, I'll take the square root, remembering my plus or minus. And I have to take that negative out with it by pulling out an I, and I get plus or minus I times the square root of 2 for my other result. So I do end up with 4 results total, plus 2 minus 2 plus I square root of 2 minus I square root of 2. Moving on to the next example, I put this underneath my special formula because it is an example with the special formula. Let's say I had x to the 4th minus 16 equals 0, and I was asked to solve this. So I want to resist the urge to add 16 and take a 4th root. Okay, I need to try to factor this. Lucky for me, I know that in order to get x to the 4th, I'm just squaring an x squared, so I can use the formula a squared minus b squared and say my a, my first quantity squared is x squared. My b, so my second quantity squared, is 4, and this will factor to be x squared plus 4 times x squared minus 4. Now, just like the last one, I am not in my factored form. This could be factored further. However, in order to solve, it's not necessary. Now that I've factored, I have a multiplication problem. When two things multiply to be 0, it means either the first term has to be 0 or the second term has to be 0. If the first term were 0, that would mean that x squared was -4 and x was plus or minus the square root of -4. Therefore, x can be plus or minus, taking out an I, as well as taking the square root of 4 to be 2. X equals plus or minus 2i. Solving the second equation I created over here, I'm going to go ahead and add 4. And I do have x squared equals 4. I'm going to go ahead and take the square root and remember to say plus or minus, so x equals plus or minus square root of 4. Well, I do know that 4 is a perfect square, and therefore my answer is x equals plus or minus 2. So here's my first two answers. Here are my second two. That is it for solving quadratic equations to the fourth degree. I do want to point out, although we won't look at any, if you cannot, I do want to point out that if I could not factor it, you can use the quadratic equation on these types of problems. We won't do any like that. You will do some when you get to pre-calc next year. Heads up. And a quadratic equation is typically written like this, and the quadratic formula takes the x from this linear term here and says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you have something instead in the form ax to the fourth plus bx squared plus c equals 0, and we don't want to factor it because of this a, we can say that the linear term here, that is now the quadratic term, so instead of solving for x like we did here, I will now solve for x squared and say x squared equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so notice that the difference is that once I get my answer here, I'm done. Once I get my answer here, in order to figure out what x is, I would have to take plus or minus the square root of whatever this gave me. So like I said, we won't do any of this. However, it's just, I think, sometimes nice to know where your next step will be in your next future course. All right, so that's it. Just those two, that tree diagram, those two examples with it. Tomorrow or Monday in class, we will do some more work with this. So I hope this makes sense to you, and bring any questions you have in with you to class. All right.